So today we're going to learn the basics of three different cloud providers, Google, Amazon, and Microsoft. So before I start, I just want to let you know that you don't have to frantically take notes or anything. All the GitHub repositories, this presentation, all the notes are on my website, so that's all you need to remember, and I'll have it up on a bunch of different slides. So why do I want to give this talk? Being a self-taught developer, it means your education is kind of ad hoc. Most of the things I learned were when I needed a project and then I had to Google how to do it. When I was working more and more in the cloud, I realized most people aren't going to have the chance to work with different cloud providers. Changing cloud providers can be very difficult and not worth a company's time. And if you do get to choose a provider on the next job, it's much easier to go with the one you're familiar with. Because despite all the documentation and demos, cloud services have a steep learning curve. They all accomplish similar tasks, but with different terminology and different design philosophies. So after today, I hope you'll have the knowledge and confidence to start creating your own projects, especially if you haven't done anything with the cloud yet. And before we dive into the tech, I want to keep you in mind of my motto for all of my tech talks. I want you to learn how to use these tools so you can do less but accomplish more. Let's make something fun but not work too hard. So what is serverless? I like this quote from AWS. Serverless computing allows you to build and run applications and services without thinking about servers. They don't require you to provision, scale, and manage any servers. You can build them for nearly any type of application or backend service, and everything required to run and scale your application with high availability is handled for you. So this is also often called function as a service. You provide the business logic, and they take care of everything else. So there are servers, you just don't have to worry about them. Serverless works best as small, self-contained microservices. Each service does exactly one thing, so you don't have to create complex interactions in each one. Instead, they talk to each other to create larger features. As an example, let's talk about an e-commerce site like Amazon and its checkout page. When a customer is trying to check out, there are numerous questions that need to be answered to provide a checkout service. Here, I'm answering questions like, are the items available? What warehouse are they in? To check shipping speed. Are there promo codes? What payment methods are available? Do they have a gift card? Things like that. By kind of separating them out into different services, it means only the service needed is running at any given time. And remember, with a serverless app, the service spins itself up when needed and then spins itself down when not. So if you don't have a lot of people using the service, you're not getting charged for it because it's not being used. And if millions of people are using your service, then it automatically scales. So it allows for independence, and the services can do anything as long as the input and output stays the same. When looking at this chart, it should remind you of relational tables or endpoints in a RESTful API. So keeping that process in mind, I wanted to create a template that can be used to make all of these services. I want an endpoint that allows you to add data to persistent storage, get that data, edit that data, and delete that data, a classic CRUD architecture. I want to be able to test that endpoint, deploy updates, and have it secured. I want my template to define all the services I use, so if they all get destroyed, I can easily spin up everything again. When you're working with cloud providers, there's basically three ways to provision your infrastructure. You can do it in the console, so just clicking around on the UI. You can do it via command line, or you can do it via configuration file. I really want to do a configuration file because it's the most, it has that history, and it's the easiest to spin up again. You don't have to remember the commands that you ran before. You just have one configuration file. So it's kind of, it goes from easiest to hardest in terms of how you use it, but it goes from worst to better, basically. So here's the following questions I want to answer about each of the cloud providers. I not only want to answer them, but then test it myself and save it in the repo. I messed up that slide. So not to discourage you, but my first lesson with all these providers is that they were way harder than they looked. Setting up a quick example in that UI is fairly straightforward. And then making it in the command line is a little harder. But even then, it doesn't always work. Setting up an app in a sustainable way so that it can be production ready was much more difficult. There are a myriad of options on everything you do. Error messaging can be obtuse. And hopefully you're a little sympathetic as engineers that has tried to write an error message for someone to understand. But I'm telling you this so you do persevere. There's a steep learning curve, but sustaining and scaling the system makes it worth it. What I'll go over today won't give you all the answers, but hopefully it'll give you that step up so you don't run into all the walls that I did over and over again. So let's start with the services. What are each of the services needed to create my microservice? How do they work? How do they play nicely with each other? I asked myself, what was the easiest way to store an item with an attribute for each service? What's the serverless tool to access that data? And how do I create an endpoint for that service? So this is what I decided on. For AWS, it's all separate, so it's API Gateway, Lambda, and DynamoDB. API Gateway is a dedicated service creating a routing. If you know Python, it's like Flask or Django, just a web framework. Lambda is the function where it parses the request and accesses the database via an SDK, so it's just all your code. And then DynamoDB is a non-relational document storage. I chose this database because it's the best integrated with the serverless services on AWS. If you're used to SQL and haven't worked with a non-SQL database like MongoDB, you have to be careful because it can quickly get messy if you don't control the input. You should think of databases like this as more like a dictionary in Python or a hash. You have an object with a key and whatever values you want. I use it here because it's fast and easy to set up, and it tends to not have too much complexity with one of these small tasks architectures. It doesn't need foreign keys if it's not touching any other tables. So I tried setting up MySQL, but it requires a whole slew of services. That's when you need your VPCs and your security groups, and it's just a huge pain in the butt. And it wasn't worth it when I just needed to store a single table. For Azure, I use HTTP Trigger, Azure Function, and Cosmos DB. You'll notice Azure named its function to represent what it is, literally a function. It's points in its favor. I also want to point out the entry point to a function is not another service. There's no separate API gateway for Azure, and you'll see for Google as well. So instead, Azure has this concept called trigger and bindings. A trigger is anything that can call a function. In this case, we're going to use an HTTP trigger, which will handle the routing. You can also trigger with other services like a file landing in storage or a row changing in a database or a log line. Binding is the output of a function. In this case, the binding output is going to be Cosmos DB. The data store is flexible and holds a variety of collections. So I use it as a table and then access my data via SQL queries because that's what I know how to use. I chose Cosmos DB because it's built in, recommended service for functions. So I hope you're starting to notice a trend here. It's like whatever they said to use is what I used because that's what they had the most documentation on. For cloud, they had the exact same HTTP trigger, cloud functions, and then their database was Cloud Firestore. It's like Google and Azure had a meeting and both decided that the functions are called functions. AWS didn't join that meeting. They also got a point for that. So they get negative points for the biggest problem with Google, which was the combination of documentation. So there's something called App Engine and Cloud Function, and it's super confusing. So when you search for one, sometimes you'll get documentation for the other, and I just want to point that out in case you're looking for something, and you're like, this doesn't look like what I was just writing. You probably accidentally brought up App Function instead of Cloud Functions. App Engine instead of Cloud Functions. They do similar things, but the Cloud Functions is kind of that pure serverless, and the App Engine is a little more complicated. Let's see. So what I liked about Google is that it uses Flask. So if you already know Python, you're already using Flask. It's great. You can just upload your function as is. The testing was really easy because of that. The routing is tied to the programming language you use, unlike Azure or AWS, where the routing is kind of separate. But in practice, that really didn't make a difference. It was actually just kind of nice because I knew how Flask worked already. Okay. So if you're anything like me, you want to code as soon as possible. You're so excited to solve that problem. You just want to get in, write your business logic, and get out. So I wanted to test each provider on how fast I was writing code. A nice feature of all three of the providers is the ability to try things out in the UI before you even have to create your GitHub repository. This is the best way to start, but please don't end there. So you can see how the service can connect, get things launched, play around without having to worry about syntax. And it's definitely possible to make an entire project that way, but you're not using source control or IDEs that make collaboration possible. So I made my fresh GitHub repository and got started. For AWS, I use this tool called SAM. SAM is a multi-use open source tool. For this section, doing a SAM initialize does the initial directory setup, including a sample hello world function. It includes a README that doubles as the tutorial for the setup. I was able to go into this app.py file and start working. I only started running into trouble when I had to add a library, like I was like, oh, I like simple JSON rather than the built-in JSON library. It was way more difficult than you'd expect. For authentication to my AWS account, I set up a config file and a profile because I had multiple AWS accounts on my computer, and that's all in the README. And then I set up all the secret configurations as environment variables. It wasn't built in, so I had to handle the storing and deploying of the environment variables myself, which is a pain. One interesting step is that I had to confirm my identity via a phone call, which took a few hours to get to me. So I was like super confused why like nothing worked for a couple hours. And then I like gave up and they called me and then everything suddenly worked again. I'm like, oh, maybe you should have said, hey, we're waiting to confirm your identity. But it's like one of those things that no one tells you and then it just gets to be very frustrated. So just look out for that if you don't already have an AWS account. For Azure, they have something called FUNC or Func. It's kind of an all-purpose tool like SAM that has a init, it sets up everything. It's straightforward and walks you through setting up your first project. One warning is that all the installations take a long time. So when I was working on this, I was like, okay, I have an hour to work on this. And then it took like 2 hours to install everything, so I had to give up for the day. So I use this tutorial called Create an HTTP Triggered Function in Azure, and everything worked great. I really love the initialization on here. It handled all the password storing on my computer. I didn't have to handle any of that. It just really set up very nicely. When it gave me my sample function, the actual Python looked very strange because of some formatting. It kind of seemed more like Java. I was like, did I accidentally hit Java instead of Python? But once you kind of understand the trigger binding dynamic of in and out, it starts to make more sense. And then all the local settings are handled really well. Like I didn't have to think about it. It like gave me a file, and when I said deploy, it deployed it, and I didn't have to worry about how I was gonna, set that up. And there's so many different ways to set up environmental variables. It was nice that it handled it for me. So for Google, it wasn't a single tool that got me up and running. They didn't have anything that was just like initialize a new project. Instead, I kind of cobbled together a bunch of tutorials. I started with it in the UI, and then I downloaded the function to see what it looked like. It did not include a configuration file, so I was very confused. But it actually didn't need it, which is why it was confusing. So in the meantime, they had a Python samples repository, which was actually really great. So it had like a bunch of different functions that other people had already written. And I was able to pull that in and test it. And instead of, I'll talk about this more about in testing, but I didn't have to like launch a local instance of it. It was just a Flask app. So I just got to test my functions that way. And then for authentication, you just set up a key, download a file. And for environmental settings, it's similar to AWS, where it goes into a config file and you store it in their version of a secure key value pair. So AWS is called Secrets Manager, and in Google it's called NDB, and it's all encrypted, and you just have to be careful not to put it in your GitHub repo. So I keep hammering on this, but in any cloud service, you want to programmatically describe the infrastructure as much as possible. This means the configuration for the app is written out and can be stored in version control, and you can see what's happening, and someone isn't just going in and deleting a database and no one knows how they did that. So, for example, Amazon uses a tool called CloudFormation. CloudFormation reads either YAML or JSON, and in that file, you can say, I'm going to make a table, call it this, give it these settings, have this index, and if you want to add or change something about that setup, you want to put it in that configuration file. It allows for multiple environments, emergency recovery, things like that. It's a professional level project. You'll want at least one staging environment testing these out before you release to production. And having these configurations files made environmental setup very easy. I don't know if you've ever provisioned multiple environments on AWS, it can be kind of a pain because you have to just like figure out all the settings and everything like that. With serverless, it was just like, give me a new architecture, here's the new name of it. So like I was having fun with it, making a bunch of different environments, my names and animal names, and just going to town just to see if it worked, and it came up in a few minutes and it was awesome. I was able to run it and then bring it down. So I talked a little bit about SAM and CloudFormation, and I want to talk about how they combine. So basically, SAM is a way of making CloudFormation easier. So CloudFormation is that YAML or JSON file, but it can be very verbose. SAM basically takes that and makes shortcuts for it. So I like to start with a SAM YAML file and write it out in that syntax, and then use SAM to convert it to CloudFormation, just because it's easy to write. But they're very tightly coupled. So if you want to use something in Amazon that's not covered by SAM, you just put the CloudFormation syntax right into your YAML. So for example, I wanted to use Secrets Manager to store an API key, and SAM doesn't have the capability for it. So I just looked up the CloudFormation syntax, put it into that SAM file, and when SAM converts to the CloudFormation, it knows, oh, this is already in CloudFormation syntax, let's just push it through. So it's a nice way to start with the SAM. That way it kind of like eases you into how to set it up, and then you can add complexity later on. One thing to make sure of that I actually learned recently is that when you're building stuff with CloudFormation stacks on Amazon, that you have to build everything in your configuration. So it doesn't recognize services you build outside of it. So say you built a table manually with the command line, and then you want to add it to your service, the CloudFormation template, it won't be able to connect the two. It won't be able to, it'll just say, oh, this table's already created, I'm confused, I'm just gonna crash. But if you delete that table and then say remake it in the YAML file, it'll already know it's there, and then every time you do an update, it knows it's there. So it's just kind of remember that don't make things outside of your configuration, because then it gets lost. So for an Azure function, you don't need any dedicated tool like SAM. Instead, you just have a JSON file. When you initialize, it's created for you with an HTTP trigger in, and then that HTTP trigger binding out. So all I added in was the CosmoDB binding, so my data goes in there when I post it. And then that other file called local settings, and then you can add settings in there and it'll be able to find it. And then you just add a flag to deploy to make sure, hey, always deploy my settings. So it's really straightforward. So for the Google function, there was no config file, which was like, since it was the third cloud provider I was looking at, I was so expecting this configuration file. And if you see any references in the documentation to app.yaml, that is for another service. That is for App Engine. And the only connection to another tool, other tools, is basically through the SDK inside the function. So if you want to access a database, you don't say, do it in the configuration, you say access it in the function. And then if you need something more complex than what's provided, that's when you want to move to App Engine. But the simple way is to just do it in the function. So one feature all these providers have in common is OpenAPI. You might know it as Swagger. It's basically standard for describing RESTful APIs. And that's what you'll want to use to design your API. It's like the only thing they all do the same, and it's awesome. So if you want to change over, you can just take your API to any of those services. It's especially crucial to define your API for the databases I picked, because it helps with things like payload validation. Otherwise, everything will just throw into that database. You can make fields on the fly. It won't validate it at all. So it's good to know it's there. Now that I know where the code was going to go, I want to do some testing. Especially when I'm working with these brand new tools, setting up tests helps me learn how to use them. And I used Python debugger tool to stop the code and evaluate the different scenarios on the spot, which was really nice. So in AWS and Azure, The unit tests were all fairly similar to other Python projects. For any outside calls, like calls to the database, I mocked it because you don't want your unit tests calling outside services. Otherwise, it's not a unit test. And it doesn't look like it's doing it. It's like kind of like dangerous. It doesn't let you know like, hey, I'm calling a database in AWS when you're running this unit test. So just be careful when you're running it. Kind of check everything and make sure you've mocked any outside calls, because it also could be spending money accidentally, which is like a very common cloud provider problem. Ooh, and it could also get confusing if you have multiple people calling the same database and running these tests. They don't know what's happening. For Amazon, I was able to get example payloads from the console, and it's all in the Lambda console. For Azure, I just kind of played around with the functions until I figured out how to mock a request from that HTTP in to make sure my requests are all coming in correctly. One of the nice things, too, about being able to set up environments so easily is that if you want to do that full integration test, and I think I talk about this a little more, it's in my next slide, is that the easiest way to do it is to just spin up a new environment and then start hitting those endpoints with something like Postman or curl, and then you just delete that environment. Like, you're done with it. It's just a really nice way of spinning things up quickly and testing the way it is in production. I'm sure many of you have experienced this where your development environment is different than production, so things work fine, and then you get to production, it doesn't work at all. So that's really one of the nicer features of being able to spin up all these random environments that you can test as much as you want. Let's see. So you can do some local testing. You kind of like spin up fake environments on your machine, but it's not exactly right. So it kind of suffers from that problem, but it's a good first start. You can do it with the SAM and the function with AWS and Azure. One library I really liked that I always recommend in Python is VCR. So VCR, you can test your payloads and it will record it and you can save it in your repo. And it's just like a really nice like side tool that I like to use. So I wanted to throw that out there. So for Google, it's the same as any Flask app. I used what I found in the repo. I was able to create unit and integration tests that use PyTest, and it was just really nice. It was one of the nice features of them being really supportive of kind of the open source frameworks. So one thing to note is that all of them suffered from like really poor error messaging while doing tests to one degree or another. Amazon had my favorite one where it just said times out without telling you what took so long or why. It would, something's not connected correctly. Oh, the error is times out. All right, well, that doesn't make any sense. But eventually, I kind of got them all to go through. You kind of just have to persevere. And that's one of the, I just want to push you through, like, it's all a pain, but you'll get there. And I've given this talk and I've told people who work there, so maybe one day they'll improve their error messaging. So once you got your code working and tested, it's time to deploy. I always deploy manually first just to make sure it works. Amazon and Azure use those same tools. I let Sam and Func to package deploy the applications. Let's see. For Amazon, I want to let you know that you're deploying that CloudFormation stack, and that you're not going to get it right the first time or the 5th time or the 20th time, but you'll eventually figure out what the syntax is. For automated deploy, the recommended tools is called Code Pipeline and GitHub. When I set those up, it was actually pretty cool. I just connected my GitHub repository, and I was able to say every time I deploy a master branch, reload the environment, which was nice. I'm going a little faster since I'm starting to run out of time. For Azure, you deploy using that function app. So one warning here is that logging isn't always necessarily turned on, which can also be super confusing. So for Azure, it's called Application Insights. So just make sure to go to the console and turn it on. I like to think of cloud providers as Spirit Airlines. Like, they don't turn anything on or charge you for anything without you telling them, but then they charge you for everything. So just be careful to make sure to turn it on. And one thing with the Azure SDKs, I had some problems, but I realized it was because their Python is in beta mode, and I wasn't going to learn a new language for this test. So just keep that in mind when you're working with it, if you're working with Python, which I think is hopefully it's a popular language here. And then they have a tool called Azure DevOps. It's similar in style to Amazon. You connect your branch with GitHub, and you have this pipeline that every time you hit the branch, it automatically updates things, which is pretty cool. One thing you have to keep in mind is that you have to make something called a pipeline and release. That really confused me when I started. Let's see. Oh, and the pipeline is where you put things like the Python version, your tests, your code quality tests like Flake and PyTest. And then the release actually deploys it. So Google, the only thing that's different is that you have to mirror your code in their repository to get everything to go up. But this actually was the fastest deploy process I had for me. It was basically like I was missing one permission, and that took me forever to figure out. But then after that, everything worked very smoothly. So it had the best error message, which was, error with this, run this command to fix this error. And I was so excited until I ran the command to fix the error, and then it gave me syntax error. And I was like, oh. But I eventually figured it out on the console. I was able to get the context. So let's see. Yeah, after all the issues with that, the automated deploy on Google was great. I'm going to talk real quick about security. So as of now, I've been kind of building an API that anyone can access. If you had the right, endpoint, you could access the API. But you don't want to, whether it's a public API or a bunch of internal services, you want to control who accesses it and when. And you don't want to allow unlimited access even from internal services, because if one service breaks, it can, cascade and bring everyone else down. So it's also helpful for compliance. So if you deal with something like PCI or healthcare compliance or credit cards, you can limit that data access between them. And then finally, you want to limit developer access to change the infrastructure, because the engineers will just press buttons and will be like, oh, this seems fine. For Amazon and all the other ones too, they have something called IAM, Identity Access Management, I believe it stands for. It is so confusing because it's so granular. Every little thing you could do in the services, you need a permission for. So at first, it just seems like a huge headache, because you're like, oh, I just want this Lambda to talk to this database, and why do I need 17 permissions? But the more you do it, the more you get used to it. Basically, I do this process of, I try to run something, it doesn't work, it says I'm missing a permission, I add that permission, I try to run it again, and then I kind of repeat that process over and over again until I actually have the right set of permissions. So just don't get discouraged. You'll eventually have the right set of permissions. And it's basically the similar structure in all three, where you're just saying, I want this service to be able to read this service. I want this service to be able to write to this service, and kind of just connecting them all and giving them explicit permissions. And then just being careful, if you give too many permissions, see if you can dial it back. It's just a safer way to run it. Another way to do it is with API keys. And that's what I've been doing for when I'm touching it externally as well. It's just exactly what you think it is. You can automatically generate API keys using your CloudFormation file, and then just hand those API keys out. Let's see. One nice thing about AWS, they have a tool for handling user security called AWS Cognito. It lets you set up user pools with different permissions and automatically assign users as they sign up. It also, uses social login and things like that. I highly recommend just letting it handle this problem for you, which is nice. Everything in Azure is a very similar design. Let's see. They have a secrets manager just like AWS. They have the API keys. They have IAM and all that jazz. One thing they have is called Claims Principle, which I did not dig into much because it's only available in .NET. But if you're a .NET user, you can go in and use more of that. Hopefully, they keep bringing more and more features to Python, so I'll actually use them. Let's see. So Google does pretty much the same thing. They use a tool. They use IAM and then OAuth. And there's also a tool called Firebase that lets you authenticate through the social logins and email password, which was really easy. And the OAuth, if you haven't used it before, it's a way of letting the user log in and agree to the permissions you ask for. So if you've used any app, you've probably used OAuth because it says like, oh, can I have permission to your contacts so I can text them and send them ads or something. So it really makes it super easy. They're like, copy and paste this code. And I was like, great. That's exactly what I wanted this whole time. And it's all generated for you. So one question that comes up often with serverless is observability. How do I know my function is running when it's not actually running, when I don't use it? With traditional server, you can kind of ping, let you know, hey, I'm still there. So just get those logging tools on. You can connect them to logging tools you already use. Adding Sentry was like super easy. So I definitely recommend that. But any other tools, there's a way of like plugging it in. Let's see. That's exactly what I just said. Oh, and Google was the only one to turn on logging by default, so that was really nice of them. And they also had a feature, which I thought was really cool, that if you just hit print in Python, it puts it to the logs. And I was like, oh, I already know how to print. Fantastic. So we're finally near the end. I hope I didn't talk too fast near the end. I probably should have had less slides, but it's kind of like this huge, monster. It's been an epic journey, and I hope you've learned something as much as I have. I've come to some conclusions, but I don't want you to take it as like dogma, like, oh, Michelle told me to use Azure. I definitely got to use Azure. They're always improving all the time. My goal instead is for you to give you a framework for deciding for yourself, like knowing what questions to ask when you're deciding which framework to use. So I want to know what is available, how do they connect, how fast can I get started, how do I describe infrastructure, how do I test everything, how's their CI/CD pipeline, can I secure the app, and can I monitor what's going on? So kind of the general, how many did I put here? 7 big parts of an app. So let's ask, I was able to answer all these questions for all these providers. They share some of the same design patterns and architecture, even if they implement them in different ways. So how to decide what to use? Let's start with the technical questions. What language are you using? I use Python because it's the language I'm most familiar with. But if you're using .NET, Azure was the big winner. Go to your provider and see how many examples are in the language you want to use and how many services support it. Are they in beta? Do you prefer tried and true? Are you comfortable with tools being in beta? It seems more risky, but then, if this isn't like a huge project, you get more input on the final product. You can actually talk to the people of these companies and say, hey, this isn't working, please fix it. And then let's talk about end goals. How do you want to use it? Do you work at a company and want to test the waters with a serverless microservice? Then your answer is what provider they already use. I found when trying to convince a team to adopt a new thing, it's best if it's only one thing at a time. So you want to submit a pull request of 5 new features. I don't think you can convince your CTO to use a new provider and a new architecture. So just keep that in mind. If you're instead looking to just grow your skills to be more marketable, look at the companies you're interested in working for and see where they're using. AWS has the biggest market share. So if a company uses a different provider, you're going to be even more demand. There's just not as many Google architects and Azure architects as there are AWS. And of course, if you want to work for any of those companies, use those tools. If you're looking to create a new business, I would contact them each directly and see who will give you the most credits, because they love your business and they want to have it and they want you to start with it. Because if they're nice to you when you're small, you'll be nice to them when you're big. So ask them what they need. And then if you're just looking to have some fun, then I say use Azure because their development advocates are the most fun, and also because Microsoft is always the unexpected choice for fun. Amazon is the OG of cloud providers, and it shows. It has an extensive array of tools and is used by most of the marketplace. But in the fast-moving tech world, that can be a downside. The other providers were able to see how they worked and build on them better. Azure has a really interesting design. I love their trigger and binding concept. And once I realized how it worked, everything kind of fell into place. It also had the easiest quick start, but it's in beta for Python, and I still haven't gotten things entirely to work because of that. So just be careful if you're using Python. Google uses Flask and its own routing system, which was nice. because it was a tool I was already familiar with. And it should be if you've already made any RESTful APIs in Python, which is nice. The error messages weren't helpful. The fact that I actually got a response on my ticket was a big plus. I didn't talk about support a lot, but there's kind of different ways I did it. I tried contacting them. AWS and Azure, AWS never responded to me. Azure responded to me weeks later. Google responded to me in 24 hours. I posted on all their message boards. No one responded to me. I posted on Twitter and Slack and didn't get a lot of response either. So just keep that in mind when you're working in Google, which is actually the fastest support. It can be very easy to get overwhelmed by this. I found this project overwhelming. I would say it took me about 80 hours to do all these projects. I don't want you to have like 15 pages of documentation open and think, I'll never understand this. You will. From working on this talk, I found that most of the documentation is detailed in every single feature, but not great on that user story. Like there was no good, like, I want to create this kind of app. What do I do? So if you want to find a specific flag on a specific function, it's there. Hopefully over time, more of these user stories will get written. Maybe you'll write them. That'd be super great. Please do. Here are the repos. They're all on my website as well. And you can just find them in Michelle and GitHub. I'll update them as I add new features. I actually have some stuff I need to add to AWS that I'm working on before. Feel free to contact me about any of them. If you have any questions today, I don't know if we have a ton of time, but you can always find me on Twitter. And if you have not gotten sick of hearing me talk, I host a podcast called From the Source, where I interview people in tech to answer the question of what tech jobs are really like, both the good and the boring. And I should make this talk shorter. Thank you very much.
Well, thanks to Michelle for this is a great talk, and it's obviously a very dense subject. And if you weren't here yesterday, all these presentations are being recorded, so you'll be able to view this later, a week or two later, they'll all be available. And we do have time for questions. So all I'd ask is, Michelle, if you repeat the question.
Oh, thanks for the great talk, Michelle. I have a question on if you had to, basically, I think what I took away from the talk is that which cloud provider you choose has a lot to depend on what you're trying to accomplish. Mm-hmm. So if you're doing a personal project without any restrictions by company, which cloud provider would you kind of start off with, given it's like your personal project?
So it depends on the language. So if you're using Python, I wouldn't do Azure. That's just a little hard right now because it's still in beta. I would say either Google or AWS. Google, if like you don't know a lot about cloud providers, the fact that Google actually answered my question within 24 hours was just really nice. So if you're kind of just starting out, so it's just a nice way, and then it can ease you in. But just remember that AWS is most of the market. So if you're looking for a job, most people are and you want to do some infrastructure, they'll probably ask you about AWS. But if you know one of them, you kind of learn the other one. It's kind of like learning different languages. Once you're proficient in one, you can start to learn the other one. But I really liked the support that Google provided.
Thank you.
Well, I just want to thank Michelle one more time for doing all the hard work and sharing this with us. And I'd appreciate if you give her a round of applause.